各位老师、同学们，大家上午、下午好啊！大家能听到我的声音吗？
能听到宋老师，没问题。
我的声音可能有点小，我大点声啊。那好，那我就开始组织今天的会议。各位老师、同学们，大家好，我是沈阳大学区域污染环境生态修复教育部重点实验室的老师宋晓明。今天下午这个上半段的会议呢，将由我为各位同学和各位老师来进行主持。很荣幸啊，在这个这次会议中呢，能够跟各位老师同学相聚在这个会议里。也在每个同学汇报以后呢，也希望咱们同学啊能够多多的提问问题，因为我们每个人的专业方向啊，或者是这个研究领域也不尽相同，所以我们看待同一个问题的这个角度也可能不同。因此这个提问的过程呢，也是一个我们获得新的灵感的一个重要的这个途径。也因此呢，通过提问呢，我们也可能碰撞出一些新的想法和一些新的思路。行，其他的我就不多说了，咱们开始今天下午的专题报告。首先呢，来请第一位同学是来自东北大学的冯雨婷同学。
喂，老师你好，能听到吗？
可以听到。
开启视频。大家好，我是来自东北大学的冯雨婷。我汇报的题目是铁和铜矿物对饱和多孔介质中浮选药剂迁移的影响。下面我将从选题背景、黄药的迁移、黑药的迁移、研究结论4个方面进行介绍。第一部分呢是选题背景。通过阅读文献可以发现，采矿活动在带来巨大经济利益的同时，也引起了生态环境的综合污染。研究表明，金属矿山的开采已经成为重金属污染物的主要来源，而金属矿山开采中所用到的选矿药剂大多是有机污染物质，而且没有经过环境毒理以及环境风险的评价，会对环境造成很大的污染。而且根据相关研究可以知道，浮选药剂与重金属会形成络合物，改变彼此的迁移转化行为，增加矿区的复合污染风险。目前大量的研究关注重点都放在了浮选药剂捕收矿石的机理以及其降解机制方面，而很少研究浮选药剂在土壤中的迁移特性以及存在重金属与选野药剂交叉污染的问题。研究内容分为2个部分，一是以丁基黄药和丁胺黑药为对象，分析其在饱和多孔介质中的迁移特性；二是揭示石英砂表面负载铁和铜矿物对丁基黄药和丁胺黑药迁移过程中的影响机理。我们先制备了富铁砂和富铁铜砂，然后以相同的方式制备了负载在石英砂表面的铁矿物和铁铜矿物。通过 SEM、XRD 检测可以表明，富铁砂表面所附的矿物就是真铁矿，富铁铜砂表面所附矿物为真铁矿复合氧化铜。然后是，在丁基黄药的迁移实验中，分别探究了介质富铁量和富铜量对其迁移的影响。可以发现，丁基黄药在石英砂体系下迁移能力较强，在富铁砂体系下的迁移，受到了一定程度的抑制，而且随着富铁量的增加，丁基黄药的迁移能力也减弱了。而在富铁铜砂体系下，无论介质的无论介质含铜量高低，丁基黄药的迁移都完全受到了抑制。由此可以表明，石英砂表面负载铁铜矿物会通过物理化学等吸附作用拦截丁基黄药，从而限制或阻止其在介质空隙中的迁移。 为了探究铁铜矿物和丁基黄药的吸附机理，进行了丁基黄药在石英砂和金属负载石英砂中的等温吸附实验。等分吸附实验结果和模型如图所示。根据实验结果可以看出，石英砂对丁基黄药的吸附能力较弱，对富铁砂的吸附能力较强，二者在一定范围内都接近线性的Freundlich 形式。而富铁铜砂对丁基黄药的吸附量较大，更趋向于朗缪尔形式。等温吸附参数 Kd 可以用来评价丁基黄药在介质表面吸附亲和力的大小。模型拟合结果显示，富铁砂吸附丁基黄药的 Kd 值大约是石英砂体系的2.4倍，表明负载真铁矿在一定程度上提高了介质对丁基黄药的吸附能力。而富铁铜砂体系下的 Kd 值约是富铁砂的20.3倍，也就说明微量氧化铜的存在大大提高了介质对丁基黄药的吸附。为了进一步验证吸附和迁移机理，我们采用了真铁矿和真铁矿复合氧化铜吸附丁基黄药后得到的样品进行红外检测。通过对比吸附前后的红外谱图可以看出，真铁矿吸附丁基黄药后没有新的特征峰出现，说明其对丁基黄药的吸附是以物理吸附为主的。铁铜复合矿物吸附丁基黄药后出现了新的特征峰，说明氧化铜的负载使得介质表面对丁基黄药的吸附转化为化学吸附。为了进一步验证化学吸附产物，继续对样品进行 XPS 检测，结果发现吸附丁基黄药后的样品的XPS 全谱图中出现了硫元素，且吸附后铜的特征峰发生了变化，铜的俄歇普的动能降低，按样品中铜组分所处的那个化学环境以及能量状态也发生了改变，原来的二价铜全部被还原为低价态的一价铜，因此可以推定丁基黄药在铁铜复合矿物上的吸附产物为丁基黄原酸亚铜。然后就是在丁胺黑药的迁移实验中，我们分别探究了不同条件对其迁移的影响。首先探究了金属种类对丁胺黑药迁移的影响。嗯，富铁砂，我们可以发现，丁胺黑药在石英砂、富铁砂、富铁铜砂体系下的迁移能力逐渐减弱，且丁胺黑药在富铁铜砂中迁移的起始穿透点，它明显向右移动。然后，为了分析丁胺黑药初始浓度是否会对其在金属负载石英砂体系中的迁移产生影响，比较了60毫克每升和20毫克每升的丁胺黑药分别在富铁砂和富铁铜砂介质中的迁移动态。可以看出来，就是低浓度有利于丁胺黑药在富铁砂介质中的迁移，而在富铁铜砂介质中的时候，随着丁胺黑药浓度增加，其迁移能力增强，具体表现为穿透曲线中的 C 比 C0max 增大，穿透点提前，回收率增加。最后，我们还探究了金属负载量对丁胺黑药迁移的影响，发现无论介质富铁量的多少，丁胺黑药在这两种介质中迁移的穿透曲线都是相似的，峰值、浓度和回收率都是相近的。丁胺黑药几乎都是完全穿出，这说明介质富铁量的多少不会对丁胺黑药的迁移产生明显的阻碍或滞留作用。而随着含铜量从0.018毫克每升增加到了0.055毫克每升，丁胺黑药的迁移能力受到了明显的抑制。由此可以表明，石英砂表面负载铜矿物会通过物理或化学吸附作用，拦截丁胺黑药，从而限制其在孔隙中的迁移。为了进一步验证吸附和迁移机理，采用了真铁矿和真铁矿复合氧化铜吸附丁胺黑药后得到的样品进行红外检测。通过对比吸附前后的红外谱图可以看出，真铁矿吸附丁胺黑药后没有出现新的特征峰，说明其对丁胺黑药的吸附是以物理吸附为主的。嗯，铁铜复合矿物吸附丁胺黑药后出现了新的特征峰，说明氧化铜的负载，嗯， 使介质表面对丁胺黑药的吸附转化为化学吸附。推测丁胺黑药在铁铜复合矿物上的吸附产物为丁基硫代磷酸铜。根据上述实验结果可以看出，丁基黄药和丁胺黑药在富铁砂和富铁铜砂中的迁移情况有较明显的区别。富铁砂和富铁铜砂对丁基黄药比丁胺黑药具有更显著的抑制效果，而且丁胺黑药和丁基黄药的分子式有较大的不同。丁胺黑药的相对分子质量会较大，其性质也相对丁基黄药会稳定很多。对比丁胺黑药和丁基黄药与硫酸铜的反应方程式可以发现，在硫酸铜与丁基黄药的反应式中，二价铜会被还原为一价铜，且产生双黄药，而丁胺黑药只是简单的络合反应，没有价态的变化。因此可以得出，真铁矿存在会对丁基黄药的迁移产生一定程度的抑制。迁移过程中，丁基黄药的组织归因于真铁矿对其产生物理吸附，而真铁矿的存在不会对丁胺黑药的迁移产生明显的阻碍或滞留作用。而在氧化铜介质中迁移时，丁基黄药和丁胺黑药因异与铜发生化学吸附，生成络合物，被堵塞在介质孔隙中，使迁移存在不同程度的抑制。在富铁铜砂体系中，随着丁胺黑药浓度的增加，其迁移能力增强。我的汇报完毕，谢谢大家。
好，感谢冯同学的精彩汇报啊。其他同学有一些有问题吗？其他同学要是没有问题，这个冯同学，我有一个疑问想问你一下啊，就是在你做这个无论是吸附实验和迁移实验的过程中，那个其他的环境因子，比如说 pH 值啊，或者是这个离子强度啊、温度啊等等这些影响，你探究过它对你这个迁移的影响吗？
那个老师，这个进行完，下一步就是这些不同条件的影响，比如说 pH、离子强度、离子种类等等。最近在探索这个。
这个现在目前这个你所汇报的这个成果还没有发表呗，是吧？
呃有一部分是发表了的，有一部分正在投稿。
行，好，谢谢啊。其他同学还有问题吗？好，那其他同学要是没有问题的话，咱们就进行下一个汇报。行，再一次感谢冯同学啊。下面呢，我们请江苏大学的王小旭同学进行专题报告。有请王同学。
嗯，老师可以看到我的屏幕吗？
好，可以看到。
各位老师、各位同学，大家下午好，我叫王小旭，来自江苏大学管理学院。我今天汇报的题目呢是太湖流域城镇化进程中的水污染的问题。我们主要是从管理学的角度来探究城镇化进程中的一个农业面源污染。我的汇报主要包括以下几个方面。首先是研究背景。我们都知道，我们国家长期以来都是采取的是工业优先发展的战略。但是以农治工的战略定位促进了城镇化和工业化的快速发展，然后农村发展的很多问题都被忽视，其中农业面源污染就是影响农村生态环境和用水安全的一个重要的问题之一。在城镇化的进程中呢，有很多农村人口向城镇转移，促进了农产品需求的增加和经济的发展。但是农产品产出压力的增加也和农业用地的减少、农村劳动力的流失形成了矛盾。因此，在农业生产和生活中出现了，比如说化肥、农药超标，然后生活垃圾粗放处理等等一系列的问题，导致产生严重的农业面源污染。和工业来源为主的电源污染相比呢，农业面源污染它具有排放随机、过程复杂以及不易被监测与控制等特征，因此它的治理过程会更加漫长，治理难度也更大。当然 也有研究也表明城镇化和污染也是存在一个比较复杂的关系，也有研究表明二者呈现一个倒 U 型甚至是 N 型的关系。在这样一个背景下呢，我们关注的是太湖流域。太湖流域是我们国家位于我国长三角的核心地带，是我国城镇化水平比较高的地区，已经突破了平均的城镇化水平，已经突破了80%。但是在快速城镇化过程中，2007年太湖蓝藻危机也暴露了流域在高水平城镇化背景下水环境保护的缺失。在随后的10年当中，非点面源污染已经占据了太湖流域总氮和总磷入湖量的45%和68%。经过多年的污染治理呢，太湖流域的农业面源污染问题已经有所好转，但是直到2022年。污染的排放量仍然是远远的超出了环境的承载力。在这样一个背景下，我们做了以下的研究。首先，我们是对农业面源污染进行了核算，采用的是输出系数的方法。另外，我们通过建立一个 VR 模型进行脉冲响应分析，以及脱钩分析来探讨了城镇化进程和太湖流域农业面源污染的一个演进的过程和时空的特征。最后，我们是进行了 LMDI 的因素分解，探究了在二者关联机制中的一些关键的影响因素。第二部分是我们用到的方法和数据。首先是用的输出系数法，我们确定了4类污染源：种植业、畜行养殖、水产养殖和农村生活，以及2类污染物总氮和总磷的对应的输出系数。核算了太湖流域8个主要城市在2006到2020 15年间的一个农业面源污染的输出。然后其次是用到了 VR 模型和脉冲响应分析来探讨二者的一个动态响应的关系。然后这边是脱钩分析，我们通过脱钩分析呢，可以确定城镇化发展和农业面源污染排放的一个相对的发展速度及其所处的动态位置。我们所划分的脱钩状态呢，一共有8种类型，其中比较理想的就是强脱钩和就是绝对脱钩和相对脱钩。其中前者呢，就是表示在城镇化城镇化率持续提高的过程中，农业面源污染是呈一个减少的趋势，这是比较理想的一种状态。最后是进行了因素分解，我们考虑了城镇化4种伴随效应，分别是污染强度、经济结构、产出水平和人口因素这4种效应对于农业面源污染的影响。因为我们知道在城镇化的过程当中，可以促进技术的革新和生产方式的变革，从而引发一个强度效应，和产出效应。另外由于高水平城镇化的人口虹吸，可以促进农村人口向城镇的转移，以及2、3产业的发展，从而可以引发一个人口效应和结构效应。我们把强度效应和结构效应视为一个城镇化的质量效应，而产出和人口效应视为城镇化的规模效应。这2种效应作用的相对强度呢，就决定了城镇化进程中农业面源污染的一个演进方向，以及从而进一步来确定二者的脱钩状态。下面是我们的一些主要的研究结论。首先是我们发现，在城镇化持续发展的过程中，太湖流域的总氮排放量是持续下降的，当然这是在2006到2020年，而总磷的排放量是经历了一个先上升后下降的一个动态过程，并且在2018年以后，部分城市出现了一个农业面源污染的反弹。从污染物的来源来看，种植业和畜行养殖占据较高的比重，其次是农村生活和水产养殖，并且农村生活和水产养殖虽然占的比重比较小，但是它是处于一个持续上升的状态。然后呢，种植业和畜行养殖作为农民收入的一个主要来源，它们在农业面源污染排放中所占的比重也呈现出一个此消彼长的一个变化趋势。然后我们通过脉冲响应分析发现，我们发现城镇化可以在短期内对于农业面源污染的排放是有一个促进作用的，但是长期以来会发挥抑制作用，并且在更长时期内可能伴随着农业面源污染的反弹。另外相反，对于城镇化的冲击呢，农业面源污染主要做出一个正响应，但是我们知道这种正响应是以牺牲农村环境和流域的水质为代价的一个粗放扩张，因此我们在后续的研究中也主要关注城镇化对于农业面源污染单向的一个关联。 接下来我们做了一个脱钩分析，发现太湖流域的总氮的脱钩状态总体是优于总磷的，并且不同城市呈现出不同的一些脱钩状态。比如说在常州，它的总氮的脱钩状态是比较理想的，但是在总磷的研究当中，我们发现存在多个年份出现了扩张副脱钩这种不利的脱钩状态。然后在上海除了强脱钩以外，还存在着强副脱钩等等这些不利的脱钩状态。当然，这和上海的城镇化已经达到了较高的水平，并且在个别年份出现下降，也有一定的关系。同样，从脱钩指数来看，我们也可以发现总磷的脱钩指数的波动性和城市间的差异性都是比总氮要更大的。最后我们做了一个驱动因素的分解，发现强度效应和结构效应是促进能源边缘污染减少的一个关键因素，其中主要的是强度效应。然后另一方面，人口效应和阐述效应是可以驱动能源边缘污染有一个排放增加的趋势，但是人口效应的一个贡献度是在逐渐下降的。从而我们也可以得出一些结论和启示。首先就是我们知道了太湖流域在能源边缘污染的一个主要来源就是种植业和畜禽养殖业，然后其次就是城镇化对于能源边缘污染的一个影响，在达到一定的城镇化水平后会发挥一个积极作用，但是也会伴随着能源边缘污染反弹的可能。第三就是我们发现太湖流域总氮的总磷的脱钩状态总体是滞后于总氮的，这也说明太湖流域在总氮的治理上取得了较好的成果，而对于总磷的治理仍然需要加强。最后，通过驱动因素的分解，我们发现强度效应和结构效应可以促进太湖流域的城镇化和能源边缘污染实现一个强脱钩，也就是在城镇化持续发展的过程当中，不再伴随着能源边缘污染的增加，而产出和人口效应则会促使脱钩状态向扩张增长连接和扩张副脱钩等不利的状态演变。因此，我们给出了以下的这样一些建议。首先，就是在能源边缘污染治理的过程中，不能仅依靠一些强制性的手段，比如说禁养、限养这种手段，同时也要建立一些社会化的能源边缘污染治理体系，促进多个主体的参与。在控制能源边缘污染的同时，也保障农民的一个主要的收入来源。其次就是要重点关注关键的污染源和污染物，比如说总磷以及畜禽养殖业的一个治理。第三点就是要抓住城镇化进程中一些关键的因素，比如说充分利用在城镇化进程中积累的一些技术和知识污染的一个强度。其次就是在保证农产品供给稳定的基础上，适当的调整产业结构，降低农业的一个比重。最后就是建立流域内协同治污城市之间经营互鉴的一个体制机制，建立长期动态的农业面源污染和顶源污染的监测体系，避免面源污染的缓解转向城市顶源污染的加重，形成一个联防联控的综合治理格局。以上是我们给出的一些政策启示。以上就是我今天的汇报，谢谢大家。
好，感谢王同学的汇报。同学们有什么问题吗？
你好，王同学，我有一个问题，
哎，你好。
就是这里，你刚才讲到的这个强脱钩和弱脱钩，这个指的是什么呀？能不能再，多一点解释？
可以可以。我们这里用到的是脱钩分析的这个方法，其中强脱钩呢，就是说这个是对于脱钩指数的一个计算，然后强脱钩呢，就是说在城镇化水平持续提高，而能源边缘污染的排放量是在下降的，而弱脱钩就是说二者都是在同步的提高，但是前者也就是城镇化的发展仍然是更快的，因此这两种都是一种比较理想的状态。然后，但是与此相反呢，我们可以看到强负脱钩就是一种非常不利的状态，也就是说，城镇化水平还是在出现了下降的，但是能源边缘污染排放量却在增加，就是一种不利的状态。这是我们对于不同脱钩状态的一个划分。
好的，好的，谢谢。
好，谢谢您的问题。
其他同学还有问题吗？ 那好，其他同学没有问题，我们就再次感谢王小旭同学的这个汇报。那我们继续下一位，有请北京师范大学的王凯同学为我们做报告。
好的，好的，谢谢。我先分享一下屏幕。这个屏幕可以看到吧，大家？
可以看到。
OK. Hello everyone. Very happy to give this presentation. And my topic today is the constitutive and numerical modeling for the contaminants transport in the double porosity medium with the consideration of multiphase hydromechanical coupling. So firstly, I'd like to give you an introduction about the HMC coupled model. We all know that for the subsurface rock, there are always sometimes for the fractured to some degree. And in many industry and research fields, we need to consider the hydromechanical and chemical coupling. For example, in the shale gas industry, when you study the transport of the fracturing fluid, you need to consider the two-phase flow within the shale gas formation and the solid mechanics, and also the chemical reaction happens with the solid minerals. And for the geological carbon storage, also you have two-phase flow within the formation, and the injection will cause the temperature change. So you need to consider the chemical reaction induced by the temperature change. And also you need to consider the solid deformation. And also when you study the geothermal industry and underground engineering, you found that the hydraulic flow and the mechanical deformation and also the chemical transport, they are coupled to each other. So you need to study the coupling between these three fields. And to derive the mathematical model for our hydromechanical chemical model, we use the non-equilibrium thermodynamics and mixture coupling theory. The derived steps are shown in this figure. For the non-equilibrium thermodynamics, we can obtain the entropy production within this mixture system, and we can obtain the Hermann's free energy, and also we can use the Gibbs to Ham equation to calculate the free energy of the fluid. So finally, we can have the free energy of the matrix, and by introducing a new term, deformation energy. Deformation energy is a part of the Hermann's free energy for the solid mechanics, which leads to the solid deformation. And the deformation energy can be written as this form. Here, W is the deformation energy for the total rock. And here we have the strain and the pore pressure, the fracture pressure. And next, by using the Legendre transformation of W, we can obtain the coupled relations of stress, pore, and fracture porosity. So this is for the rock stress, and this is strain, and we have pore porosity here. This is for fracture porosity. And by substituting the coupled relations into the balance equation for the mechanic fields, the fluid fields, and the chemical fields, we can obtain the final governing equations for the mechanic and the hydraulic and chemical physics. So it's easy to find that the pore fluid pressure and the fracture fluid pressure change can influence the mechanical deformation. And in the fluid phase, here we put the pore water equations. And you found that here is the influence from the solid deformation, the pore and fracture fluid coupling, and also because we have pore and fracture within this double porosity media. So there is a mass transfer between the pore and fracture. So this is for the mathematical model. And after that, we try to apply this mathematical model to a real problem. This is a shale gas industry real site, and we use this model to predict the flow back of the fracturing fluid within this shale gas formation. So this is a conceptual model. So in the shale gas industry, normally you inject the fracturing fluid into this reservoir, and this fluid will create a new fracture network between this formation. And after the injection finished, the injected water and gas in the shale gas reservoir, they will flow from the formation to the horizontal well and then flow back to the surface. So this process is a highly coupled process. You need to study the two-phase flow behavior, the solid deformation, and the chemical diffusion. And so for the boundary condition, we use the low flow boundary and fixed boundary for the lateral boundary and the upper boundary, because the lateral shale formation, the permeability is very low. You can ignore the water flow. And we set the horizontal well as the lower boundary. So in this boundary, we have the real data for the water pressure, for the gas pressure, and we set the lower boundary as free to move boundary. And then comes to the results. We compare the calculated results with the real data to validate this model. So this figure shows the water velocity, and this is the gas velocity. And according to the results, you found that the calculation results fit well with the experimental data. And we use this model to calculate the water saturation and the gas saturation within the formation. And also we calculate the cumulative, the water flow back volume. So the results shows that when the flow back ends, normally this will last for 1 week. And the cumulative flow back mass is about 532 cubic meter. And it only accounts for less than 2% of the total injection volume. And for the results of the chemical concentration, here we put the concentration for the pore and the fracture pollutants within 1 year. And the results is clearly show that the decreased rates of the pollutants concentration within the fracture, this is for the fracture, is much higher than in the pore. And the maximum concentration of pollutants of fracture after 1 year, you found it dropped to 0.29, and the concentration in the pore almost remain unchanged. And for the results of the concentration in the fracturing zone and the lateral shale, so normally after the fracturing process, you have a fracturing zone with where many new fracture generated, and this zone have a very high permeability and very high fracture porosity. But upon that, for the lateral shale, the permeability is still very low. There is no new fracture. So for the results, you found that for the lateral shale zone, there is a very significantly concentration increase. You found that this curve is increased, and for the fracturing zone, the concentration actually decreased. So this is mainly because the initial condition and the permeability, because the initial concentration for the fracturing zone is relatively uniform and with a very low concentration gradient. So as long as the water flow back to the horizontal well, this causes a concentration decrease. But for the lateral shale, the initial condition is almost 0. So the chemical will diffuse from the fracturing zone to this natural shell. So this causes a concentration increase. And finally, we use this model to calculate the mass flux of the pollutants and the cumulative mass of the pollutants injected. So the result is these two figures. As you can see, this is for mass flux, the velocity, and this is for the cumulative mass. After 100 days, you found the cumulative discharge of the pollutants and the lower boundary, which is the horizontal wheel, was about 100,000 milligram and accounts for less than 8% of the total inject amount. So the results shows that most of the pollutants still remain in the reservoirs at this time. So finally, the conclusion. Basically, in this research, we use the non-equilibrium thermodynamics and the mixture theory to develop a chemical transport model with consideration of two-phase fully hydromechanical coupling in the double porosity media. So this is for the fractured porous media. And we use the field data, the real data, to validate this numerical model. And the results shows most of the fracturing fluid will remain in the reservoir after the flow back stage. And the concentration distribution of those residual chemicals are different in the fracturing zone and the natural shell. So that's all. Thank you.
好，感谢王凯同学的精彩报告啊。我们其他的同学有没有问题或者是一些新的看法和见解的？好的，那其他同学要是没有意见的话呢，我们就再次感谢王凯同学的精彩报告。下面呢我们会议继续。接下来呢，我们邀请南京师范大学的朱敬轩同学给大家做报告，有请朱同学。
好的，老师，请问可以听见吗？
可以，也能看见你的屏幕。
哦，好。Okay. Hello, everyone. I am Zhu Jingxuan, and I come from Nanjing Normal University. Today, the topic I'm going to talk about is raindrop microphysics retrieval model using dual polarization radar based on long short-term memory techniques. Well, we know that the water cycle is one of the most important material cycles on the Earth. Precipitation is a vital component of the water cycle, and it's the main way for moisture in the atmosphere to return to the Earth's surface. The corresponding research, such as precipitation forecasts, remote sensing observations, cloud microphysics investigation, and water-induced soil erosion. There are many study fields are closely related to the microphysical process of rainfall. Therefore, researchers propose the concept of raindrop size distribution, also called DSD, from the perspective of microphysics. Simply expressed as three-parameter gamma model, including normalized intercept parameter NW, the drop median diameter D0, and shape factor mu. There are two main methods to observe DSD. The first one is the disdrometers, which is currently the most direct and accurate method to observe DSD information, allowing accurate measurement at the deployed station. For example, the impact time disdrometer generates electrical pulses in the coil when it is hit by raindrops, while the optical one mirrors DSD based on the change in electrical signal when raindrops obscure the laser. However, disdrometers are usually expensive and practically impossible to deploy densely on a large-scale network. As we know, rainfall characteristics vary spatially and temporally in nature. Studies including quantitative radar precipitation estimation, numerical weather model simulations, and soil erosion evaluation often need to be supported by those large-scale DSD results. The other useful method is using ground-based geopolarized radar. It alternately transmits vertically and horizontally polarized electromagnetic waves and receives polarized backscatter signals. There are 3 polarized parameters widely used to build polynomial regression models with gamma DSD parameters, as I mentioned before. However, we have to notice that a simple polynomial regression may not fully exploit the in-depth relationship using available observations. And our current understanding of radar DSD relationship, as well as its prediction in space and time, is inadequate. Then we raised a question: can we find an efficient and highly spatial temporal predictive method of large-scale DSD retrieval while returning the parameter relationships using machine learning methods? Therefore, this study proposed a novel DSD retrieval model that uses geopolarization radar observations based on LSTM techniques. The fitting performance and the spatial temporal prediction abilities of the model are compared with those of traditional regression methods. It is expected that the new retrieval model will be more representative and applicable on large scales. Here is our study area and available data we used. 2 types of disdrometers were chosen in this study, including impact type and laser type. Information related to location, type, and the coverage period of disdrometers is shown in the table. All data are provided by the UK Met Office. We chose 4 disdrometer stations as examples to present. To explore the general DSD characteristics at the 4 different locations, the probability density functions, also called PDF, we usually call it, of these parameters are shown in this slide. The PDF of the 3 parameters can reveal the local DSD characteristics, and the PDF diversity can be used to examine the DSD retrieval algorithm under different situations. In traditional method, at each disdrometer station, 80% of data are chosen to establish the relationship model, and the remaining data are used to calculate validation indicators, including RMSE, NSE, and MBE of fitted parameter. In LSTM models, 60%, 20%, and the rest 20% of data in each station are used to train the model, test the model, and evaluate the calibration performance, respectively. There is also a huge improvement in the fitting performance when estimating mu using the LSTM scheme. Through the scatter plots, we found that all LSTM estimators exhibit better performance than the polynomial regression method. Even the LSTM performance for mu is still a little poor compared to D0 and NW retrieval, indicating the complexity of estimating mu using dual polarization data. In order to check the performance of both models, we additionally analyze their temporal and spatial predictability. Temporal prediction ability relates to the model established using historical data being applicable to future situations. The figures show that the performance of LSTM is always better than that of the traditional model. The spatial predictability indicates whether the estimators established using data at a given location can be extended to other locations. The left figure is a flowchart about multi-site validation, and the other figure shows both RMSE and NSE Nash efficient coefficients of all prediction sites of each model, indicating the excellent spatial prediction ability of the LSTM-based DSD retrieval model. What's more, we have also carried out further research on rainfall erosivity using large-scale DSD results and published in those journals. Well, in summary, the proposed DSD retrieval model using dual polarization radar based on LSTM is an efficient tool to improve the retrieval accuracy of DSD parameters. And that's all. Thank you for your attention.
好，感谢朱同学。其他的同学有没有问题或者是看法？行，其他同学要是没有问题的话，我们就继续往下进行。再次感谢朱敬璇同学。接下来呢，也是来自南京师范大学的徐一雷同学为我们大家来做专题报告。有请徐同学。
可以看到吗？
可以看到。
好。Mr. Chairman, fellow students, friends, good afternoon. My name is Xu Yilei and I'm a master student at Nanjing Normal University. The topic of my presentation is about identification and risk analysis of compound hazards based on data driving. Firstly, I would like to introduce the background. With the global climate change, the interaction between different nature hazards has become more and more frequent, which makes the impact and the harm of hazards continue to be amplified and aggravated. Therefore, hazard presentation and mitigation work to deal with compound hazards is becoming more and more important in risk management. The effects of the interaction of multi-hazards are often very destructive, and the existing research is rich in extreme events. But the research on multi-hazards mostly focus on the multi-hazards environmental model, which treats hazards as isolated multi-single hazards individuals, ignoring the subplacing brought by the proximity of time effects. It is different from managing risk in response to compound events that overlap in space and time. Therefore, this research work is carried out based on the above backgrounds to identify global compound hazards and analyze their risks. Secondly, I would like to introduce the methods. Data-driven means starting from data. First, we need to build a comprehensive type of single hazard spatial temporal database. We use data mining combined with text mining. The left are some official data resources, including both aggregated and single hazard type data. The most complicated step is information extraction. The key of it is to analyze the sentence syntax. According to different situations, we explored and concluded 3 screening mechanisms: screening matching, dependency parsing, and the keywords extraction. Whether it's from text mining or official database, there is a problem. Geographic information is stored in the text form, so we need geocoding in this work. First, the text records are complex and device, so it is necessary to perform text parsing for place name information. Some of the problems include are follows. So we use natural language processing and geocoding, and finally pass a simple test and output the special coordinates. Next is to build a composite hazard database. First, study the temporal and spatial scope of hazards, also with the interaction relationship, and use the DB-scan for temporal and spatial clustering. On the other hand, the technology of text mining is used to supplement compound hazard events, then build a knowledge graph between hazards for relation extraction. Then we move to the part of results. The first result is to generate 2 major databases: a multi-type single hazard database containing 1,100 records and 1,000 record compound hazard event database. The spatial and temporal scales of natural hazards impact on the environment cover many orders of magnitude, and it is possible to understand the relationship between the temporal and spatial impact scope of hazards. Next, it treated the hazards with the same characteristics of temporary and humidity, and obtained the multi-hazard environmental models under 4 situations. This result shows the multi-hazards are more likely to occur in hot and humid environments, laying the foundation for identification of compound hazards. The next research result is the generation of compound hazards. It shows the qualitative representation of interaction between compound hazards. In the figure, the node size indicates the relative numbers of single hazards, and the line ones between nodes indicate the compounding possibility between types. The figure on the right shows the time series evolution characteristics of compound hazards, showing an inverted U-shaped distribution and has declined in recent years. The region-dominated compound events distribution is shown in the figure, and the results consist with hazard effects that the single hazard incidence rates of heavy rain, landslides, floods, and earthquakes, and their coupling possibilities are high on a global scale. The spatial risk distribution of compound hazards is shown in the figure, with the primary features around the sea and along the mountains. On a global scale, high-risk areas are mainly distributed in the eastern part of the United States, Japan and near the western starting point of Himalayas. They have latitudinal characteristics and belong to the mid-latitude zone. Finally, the economic losses and deaths caused by compound hazards and independent hazards each year can answer two scientific questions. In the same hazards, is the impact of compound hazards greater than that of independent hazards? The answer is yes, but don't forget that the spatial breadth and the frequency of the compound hazards are smaller than the isolated hazards, and the damage are greater. Are compound hazards more important over time? Obviously, it can be seen from the figure that damage and the death caused by compound hazards has become more and more different from that caused by isolated hazards over time. In other words, compound hazards are becoming more and more important, and it is worth spending more focus on prevention and governance. The last part is discussion. One of the innovations of this study is the extraction method of compound hazard events. Existing multi-hazard models do not consider the coincidence on the time scales of hazards, so the quantity research on concurrent compound hazards on a global scale is innovative. From the method level, spatial coding work is extremely important for the spatial cognition and the reasons of events. The risk assessment of global compound hazards are carried out the first time, revealing the temporal and spatial distribution characteristics of global compound hazards and the dominant types of units. Compound hazards cause damage with low frequency and small breadth, and becoming more and more important as time goes by. The next stage of the research will be based on this stage to provide quality assessment and the scientific basis for hazard prevention and mitigation. That's all. Thank you.
好，我们感谢许同学的精彩报告啊。下面请同学们提问。好，大家要没有问题，我们就再次感谢徐同学。接下来呢，我们请下一位报告者，有请牛津大学的胡淑仪同学给大家做专题报告。有请胡同学。
老师可以看到屏幕吗？
好的，可以看到。
好的，谢谢。那我就开始了。
好，可以开始。
Good afternoon, everyone, and good afternoon and good morning, everyone. My name is Shuyi Hu. I am a recent MPhil graduate from University of Oxford and a former research assistant from University of Nottingham, Ningbo, China. The topic I'm going to present today is environmental flow assessment for a green small hydropower plant using hydraulic habitat modeling with a focus on the benthic macroinvertebrate community. This presentation is divided into 4 parts. First, I'll briefly introduce the background of this study. So that's why I chose this topic, what are the research gaps and what this study aims to achieve. Then I'll move on to talk about the methodology, including the modeling framework, the study sites, and the field experiments that have been done. After that, I'll present the major results before drawing a conclusion and make some suggestions for further management and studies. The climate change is happening in every region on Earth. In these 2 years alone, we have been seeing unprecedented extreme weather, such as the Zhengzhou flood and German flood in 2021, and the extreme drought that lasts for months in southern China in this year. The hydropower plants, which quite often in the form of multi-purpose dams, which serve for hydropower generation, irrigation, water supply, recreation, navigation, and flood control have a crucial role in accommodating this increasing non-stationarity of flow regime and ensuring the water security for the human society. Besides, there is a significant amount of untapped hydropower potential in the developing world, especially in Asia. And as of 2015, hydropower has generated 78% of the global renewable energy, acting as the biggest source for renewable energy. Therefore, hydropower plays a vital role in fighting against climate change, achieving net zero, and building a more resilient and sustainable human society. However, the global hydropower expansion is expected to slow down in this decade, partly due to the negative environmental and social impacts of mismanaged hydropower projects, include but not limited to river fragmentation, sedimentation, and alteration of hydrological regime, which can further lead to decreasing river connectivity and the deteriorating downstream ecosystem. As a response to the negative environmental impact of water infrastructure, the environmental flow in the context of hydropower plant management in China is defined as the quantity, timing, and quality of water flows required to maintain the aquatic ecosystem downstream of water infrastructures. Depending on different water management objectives and the method used to calculate E-flow, the E-flow can be a single water flow level, such as the minimum flow or optimum flow, or a suitable flow range. Minimum flow is a certain water level of flow in the stream, below which water cannot be withdrawn to preserve target species or communities. The process of determining environmental flow is called environmental flow assessment. An EFA method can be roughly grouped into 4 categories: the hydrological method, the hydraulic rating method, the hydraulic habitat modeling method, and the holistic method. The hydrological, well, in this study, we will mainly focus on comparing the hydrological method and the hydraulic habitat modeling method. The hydrological method are top-down and desktop-based method that rely on historical flow data for the calculation of E-flow, and usually with no consideration of local ecological response. This type of method is rapid, cheap, and easy to apply. However, the direct application of the hydrological method without using local ecological data for calibration lacks ecological relevance, hence might result in unsuitable environmental flow recommendation. In contrast, the hydraulic habitat modeling consists of hydraulic modeling and habitat modeling. It uses physical habitat to link alteration in the flow regimes to the biotic responses, and is assumed to generate more ecologically relevant and reliable environmental flow recommendation than the hydrological method. However, the HHM usually requires intensive field experiments and computer modeling, especially when 2-dimensional or 3-dimensional hydraulic modeling is involved. And the HHM studies have mainly focused on fish due to their economic values and the limited knowledge about other aquatic biotas preferences for flow conditions. The benthic macroinvertebrates, as shown in the figure, are bottom-dwelling animals and have a much smaller body size than fish. The flow range that is suitable for fish might not be suitable for the benthic macroinvertebrates. While they are crucial in the aquatic food chain, the benthic macroinvertebrates have rarely been the focus of HHM studies due to the limited economic value of preserving single benthic macroinvertebrate species and the limited knowledge about their preferences for the flow conditions. In China, concept of green small hydropower plant was proposed to assist in the sustainable development of small hydropower. However, the GSHP assessment criteria has put the highest priority on satisfying the minimum flow released from the hydropower plants. However, the minimum flow of most projects have been calculated using the Tennant method, which is one of the hydrological method, as 10% of the annual mean flow with no seasonal variation. As mentioned before, the direct application of the hydrological method without using local ecological data for calibration lacks ecological relevance. And furthermore, aquatic biota tend to shift their preferences for flow conditions in different seasons, which leads to the doubt about the ecological validity of maintaining the minimum flow downstream of the hydropower, which is whether maintaining the minimum flow would actually lead to the improvement of the downstream ecosystem. Therefore, this study aims to first use a data-driven habitat model and pseudo two-dimensional hydraulic model to calculate e-flow with a focus on the benthic macroinvertebrate community. And we also aim to assess the ecological validity of using Tennant method for the calculation of minimum flow in GSHP. The modeling process consists of two parts. First, in the pseudo two-dimensional hydraulic modeling, the model HECRAS was first used to conduct the one-dimensional steady flow analysis to simulate the cross-sectional averaged water surface elevations under different discharges, which was then input into the model Casimir for the calculation and interpolation of the physical habitat variables, including the water velocity, water depth, and substrate types across the study reach on the different discharges. The output of the hydraulic model was then input into HABFAS, which is a data-driven habitat model for the generation of the distribution of the habitat suitability index across the study reach, which can then be used to produce the habitat suitability discharge curve, based on which the environmental flow could then be determined. Jiufeng Reservoir Hydropower Plant was chosen as the study area, and this hydropower plant is located at Houda Stream, which is an agricultural stream in Jinhua City, Zhejiang Province. The Houda Stream is located in the subtropical monsoon climate zone with 4 distinct seasons. As one of the first green small hydropower plants in China, the minimum flow of the Jiufeng Reservoir has been set as 1 cubic meter per second using the Tennant method. 3 field campaigns were conducted in May, which is the wet season, and September, which is the dry season, 2021, to collect hydrological, morphological, hydraulic, biological, and water quality data as for input to the numerical model and the assessment of the water quality in the stream. The results of this study have shown that the minimum flow set using the Tennant method is within the suitable flow range of BM community in both wet and dry season, with a much narrower suitable flow range in the dry season. Well, instead of the minimum flow, it is the excessive amount of flow that actually poses a threat to the local BM community when compared with the daily flow released from the Jiufeng Reservoir. The flow level of only 1 day in the wet season and none in the dry season were within the suitable flow range, while with the flow levels of the remaining days all higher than the highest suitable flow levels. The high concentration of total nitrogen and total phosphorus in the Houda Stream in both seasons indicate that the Houda Stream has been heavily polluted by the agricultural runoff, which might inhibit the ecological effectiveness of maintaining the minimum flow downstream of the Jiufeng Reservoir. And during the hydraulic habitat modeling, there are several results that have been produced by different models, including the HECRAS model, the Casimir model, and the HABFAS model. So in conclusion, as regard to the Jiufeng Reservoir hydropower plant, the minimum flow set using the Tennant method is suitable for the local BM community downstream of the Jiufeng Reservoir hydropower plant. Instead, it is the excessive amount of flow that poses major threats to the local BM community, especially in the dry season. The different suitable flow ranges in different seasons further prove that the suitable flow ranges for aquatic biota would vary among seasons. And finally, the poor water quality in the Houda Stream might hinder the effects of restoring or maintaining the e-flow in the Jiufeng Reservoir. As for the suggestions for GSHP management and further studies, first, there should be a more diverse e-flow criteria, including minimum flow and peak flows with seasonal variations, And due to the limited evidence about the ecological effectiveness of maintaining the environmental flow downstream of the hydropower plants, there should be a clearer and a consistent monitoring to assist in the adaptive management, which is learning by doing. And methodology-wise, there should be a uniform standard in habitat modeling to reduce the strong subjectivity involved and allow for comparison among different habitat models. And finally, as most of the studies have focused on the environmental impacts of a single hydropower plant, further studies are required to investigate the impacts of cascade hydropower plant and alteration of water temperature on the local aquatic organisms. This is the end of my presentation. Thank you for your attention.
好的，感谢胡同学。其他的同学或老师有没有不清楚或者是有疑问的地方？
Can you see I raise my hand? Yeah, hi. Shuyi,
Hi.
thank you for your excellent presentation. And I have two general questions.
Yep.
First, can you tell me more details about your model calibration and validation processes?
Yeah, sorry, I didn't actually mention it quite clearly. So as for the hydraulic model, I used the RMSE and NSE R squared for the calibration and validation of the hydraulic model. That is both the HECRAS and the Casimir model. While for the habitat model, which is a HABFAST model, it has cross validation inside the model, so I didn't need to actually manually calibrate or validate the model.
Yeah, thanks.
Yeah.
And second question is, do you think your method can be used generally or just focus on some specific area? Like
So,
you, yeah.
Sorry, yes. I think, so this is, HABFAST is a micro-scale data-driven habitat model, which means it requires the selection of a single river ridge as the study site. And there are also mesoscale habitat model, which focus on a certain river stretch that is the upscaling, which requires upscaling of, and you need to measure different physical habitat variables instead of the 3 physical habitat variables here. So as for application to other area, I do think it's possible, but it still requires really intensive field experiment. And the habitat model used here is a micro-scale habitat model, so it can't really be used to generate the environmental flow recommendation for the whole river. So that might be one of the limitations.
Yeah, many thanks for your answer.
Thank you.
其他老师同学还有疑问吗？好，没有疑问，我们就再次感谢胡淑玉同学。咱们后续的论坛呢，将由这个温玉娟老师继续为大家主持。谢谢各位同学，有请温老师。
Good morning and good evening, everyone. My name is Yujuan Wen, a teacher of Shenyang University. I will chair the meeting next. Now let's warmly welcome our next speaker, Alice Hammond, who came from British Geological Survey. Welcome.
Thanks so much for Professor Wen. And Alice today has some work to do, so he can't come to the meeting, and I will play his video recorded in advance. So now I will share my screen.
Okay, thank you.
Thank you. Is it all right? And maybe I will play it.
I
Hello,
can
everyone.
sing.
Good morning, good
Okay,
afternoon.
thank you.
My name is Ellis Hammond. I'm a PhD student at the British Geological Survey and Cranfield University. And it's my pleasure to be talking to you today about some research that I've done in developing a use case for data-driven brownfield decision support systems. My research and my PhD is funded by the UK Natural Environment Research Council, and also through the two companies at the bottom there, Groundshaw and WSP. So brownfield redevelopment is a complex and difficult process with many challenges, including the risk posed by contamination and geotechnical instability, the variety of social attitudes, and lots of economic constraints for redevelopment. Now, this means that a considered strategy is needed when we're dealing with brownfield land. So there's a wide range of stakeholders that are involved, from developers to local authorities to planners, consultancies, and specialist contractors, all with differing priorities, opinions, and knowledge bases. In the academic literature, public and private sector literature as well, digital tools and decision support systems have been developed to support brownfield decision makers across a range of applications. Literature and guidance tell us one thing very clearly, however, is that stakeholder engagement is the cornerstone of successful decision support system development. So to this end, in this talk, I'm going to outline our methodology and findings in developing a use case all the way to implementing and prototyping. So starting with identifying problem areas for the brownfield sector in general, identification of a user base that will benefit the most from improved digital technologies, identifying user-specific challenges as well. And these three components together create the use case. And from this, it's about creating an idea for a solution, mapping the user journey through this idea, and then prototyping, testing, and implementation. It should be said that this methodology roughly follows the design thinking methodology, which places user experience and user at the heart of the process. So this slide shows a simplified diagram of the planning and redevelopment process for brownfield sites. Existing research on brownfield decision support systems focuses on late stage applications, such as the selection of a technology for remediation or the modeling of groundwater contamination using a site-specific, project-specific data. Conversely, our focus is on the early stage of the redevelopment process at a regional scale where uncertainty is greatest and the need for data support is greatest. If you want to learn a bit more about brownfield decision support systems, I encourage you to check out our critical review paper that was published last year. It's a pretty comprehensive study on the topic and a good place to start. It's also open access as well. So from intelligence gathered from critical review work and sector-wide stakeholder engagement here in the UK, we've identified 5 key problem areas for the sector. The first one is around data access, findability, and understanding of data. So the data needed for brownfield assessment can be hard to find and bring together. The next one is about a large variation in GIS skills across the sector, meaning that currently only certain stakeholders are able to use GIS methods within their decision making. As before on the previous slide, existing decision support systems are not created with the user in mind and created in the user-friendly manner, which means they are hard to use and complicated. Existing decision support systems focus on late-stage challenges, neglecting early-stage decision-making, and they focus on environmental and contamination issues with little consideration given to the socio-economic dimension of decision-making. So moving forward from these problem statements, we identified 3 key stakeholders within a regional scale city-region combined authority that would benefit the most from an early stage decision support system. And these form our user base. So we have a strategic land use planner, a digital spatial planning officer, and a brownfield redevelopment officer. So I reached out to these stakeholders within a city region combined authority and engaged with them through means of semi-structured interviews to elicit their views, goals, and challenge areas. So the first one we are going to talk about is the strategic land use planner. This is the person responsible for all areas of spatial planning and developing the strategic plan for the area. And their goal, simply put, is to ensure sustainable planning and development across the area. The second person is a brownfield regeneration officer who is in charge of housing partnerships and grants and funding delivery for developments. And their goal is to unlock brownfield sites and ensure housing supply is met. And then finally, the digital spatial planning officer is responsible for all things digital and GIS, and they work with the combined authority and constituent local authorities to develop their GIS and digital plans. As you can see at the bottom, they vary in their digital capabilities, meaning that we need to take this into consideration when designing a decision support system for them. So I'm going to run through some of the key issues that we identified from these three users. This is identified from their experience in a decision-making process within the city region. So all of these issues are shared between two or more of them. So I've plotted them on a texture triangle-like diagram. So the first three are all around spatial data, access, and the ability to analyze spatial data. There's a variety of GIS skills and skills with spatial data. They currently feel that they are, aren't making adequate use of spatial data tools in their decision-making process, and they find accessing and just finding relevant geospatial data difficult. The next two are all about existing technological workflows not up to the task, which is hindering decision-making. The next one is about understanding ground risk. So the lack of understanding of ground risk posed by contamination and geotechnical hazard by all stakeholders and sort of non-expert stakeholders within the combined authority means that they struggle to understand this topic and would like to have tools to help them understand it in a more clear and easy to understand way. The next two are all about sustainable placemaking. So within their area, there's less interest in alternative end uses for site, such as public open space, with all of the interest being driven towards housing and for residential development. So they would like to have an evidence base to encourage sustainable placemaking. And then the final two are all about economic viability. So economic viability data is hard to gather and analyze, and a lack of understanding of the viability process by all stakeholders means that it's time consuming explaining this to stakeholders. So user stories then. So building on these challenge areas from the brownfield sector and user personas, we've identified 4 key areas where brownfield decision support systems can help to support users in the early stages of planning and redevelopment. These are the early stage master planning. So early stage master planning is difficult for decision makers. Developers in their area are less interested in alternative end uses, such as public open space, and this is not an example of sustainable placemaking. So within their organization, they want to promote the value of alternative end uses for brownfield sites. Oops. Financial viability is often the #1 factor for brownfield success. However, accessing and analyzing this data is difficult, and there's a lack of understanding of viability by non-expert stakeholders. So brownfield sites are often affected by contamination and ground instability, and there are risk and cost implications posed by the contamination and geotechnical instability to the intended development and to the end users of the site. Having an early stage understanding of the ground conditions is crucial to a project success. And then finally, the variety of digital skills means that an easy to use solution is needed. To this end, then, we are proposing a novel spatial decision support system that improves on existing work, utilizes modern presentation systems and analysis methods, and is designed with the user from the ground up to address specific problems and fit into their current digital workflow. So we're proposing 4 components to address each of the user stories, namely an assessment of land use, quantification of ground risk, a module to assist economic assessments, and an improved user interface and user experience to access and interact with these data sets. So to briefly touch on some of the technical details underpinning the data workflow then. So there's a wide variety of data sources and providers that we need to create these outputs. So you can see on the left there, we have everything from Ordnance Survey, which is responsible for, topographic and feature mapping, all the way through to the Coal Authority and Environment Agency for sort of environmental data sets. So there's a wide variety of formats that's ingested as spatial and non-spatial data formats. A large amount of pre-processing takes place within a desktop machine that includes in GIS software and other non-spatial software such as bespoke Python scripts and Excel and other CSV processing software. This processed clean data is then stored and ready for the next step. So the prepared spatial data moves from its storage database into the desktop software. In this software, various analytical methods are applied. The examples here is MCDA and spatial analysis. The methods and specific of the MCDA model and weightings are verified with the stakeholders and end users. Following this, the resulting data layers are then uploaded to cloud storage, ready to be ingested into a web-based decision support system. The final icon here is a web app that's built using a variety of WebGIS creation tools. So I've just briefly touched on the concept that we've created to solve some of these challenges, but how will it solve them? So it's going to assist early stage master planning, support evidence gathering for spatial planning, assist financial viability assessment, help to quantify and understand ground risk. It's going to be easy for novices to use, have all the data in one place, and be a web-based GIS. So it won't have any of the well-known limitations of a desktop software. So as you can see, we're addressing each of these issues, responding to challenges in the brownfield sector, and directly responding to end user need. So this solution could be identified as a T-shaped prototype. A T-shaped prototype is a highly functional and interactive prototype that uses real data, looks, feels, and performs like a fully deployable application with a range of features and functions visible at the surface. However, only specific components have full functionality. And this is an iterative development process where you kind of develop a version, test it and get feedback, improve upon it, and then you go through a cycle of development until you're happy with the level that the tool is at. So if you take one thing from this talk, let it be this. User-led design is best practice for the development of impactful digital solutions. It's crucial to have a good understanding of the research landscape and sector, meaning you've carried out robust stakeholder research, developed a strong use case, and gone through interactive prototyping. So thank you for listening to my talk this afternoon. Again, my apologies that I can't be there to present this live or answer any of your questions live. If you do have any questions that you'd like to ask me, you can shoot them across using any of the channels below. So feel free to do that. And thank you for listening to my talk today.
Okay, the video has finished, so please allow me to end the screen sharing. Thank you.
Okay, thank you. Thank you very much for a wonderful speech. Okay. Thank you. Thank you very much. And since Alice can't be there, we move on to the next speakers, please. Now we welcome our next speaker, Lei Li, who come from the University of Nottingham. Please.
Can you hear me?
Yeah.
Wait a moment, I need to share my screen.
Okay.
Sorry, I think I have to quit and reopen the Zoom. Sorry for that.
Okay. Okay, we just wait for a moment. How about we change? Okay.
Okay, can you see my screen now?
Yes.
Great.
Thank you. Please.
Okay, hi. Good morning and evening, everyone. My name's Lei Li, and I'm a PhD student from University of Nottingham. I'm in Geography department. And my research topic is about the public perception and participation of China's smart city program. So I guess my topic is more social science and human geography. And my supervisors are Fei Chen, Chris F, Ali, and Dimple. So today I will briefly talk about my research background and research objectives and my methodology and the statement, and followed by my research findings. It divided to 3 parts, including the policy analysis of smart city, media news analysis of smart city, and interview analysis with 3 actors from government, media, and public sectors respectively. And finally, I will give a brief conclusion of my research. So first, I will give an introduction and background. So currently, as we know, the climate change and rapid urbanization and land use changes already cause more and more extreme weathers nowadays, such as urban flooding and urban heat waves. So here I put 2 events here. The first one is urban flooding happened last year in July in Zhengzhou, causing over 300 people died. And there are many news reporting about that flooding event. For example, like from Washington Post, they mentioned like in the Bible, that Noah had a decade to build his ark before the Great Flood. But currently with the climate change increasing, appearing to produce like the storms like bringing amount of rain, we don't have enough time to prepare. So currently we urgently need to expand on current measures against the flooding. And also because the climate change has already made extreme weathers even in urban centers for cities and nations across our planet. So we require commitment to climate-proofing changes to infrastructure rather than just relief responses or the disaster recovery, such as the case in Zhengzhou. We need more proactive measures to facing the climate change issues. And another case is urban heat waves happened in 2015, like in Pakistan, and also causing 2,000 people like died. And here is a quotation from a journalist. Like she said, after all, climate change means we will soon have hotter, longer, and more frequent heat waves. But the conversation is different now compared to 20 years ago. Although most governments take the heat seriously because of global warming, but unfortunately, in some cases, there's still some government and media, they fail to take the heat serious until they have such crises. So that's why I want to do my research focus on the interactive and communication between the government, media, and public to improve their awareness to climate change. And that's also why there's some more sustainable and green solutions concepts proposed in recent years. For example, the smart cities proposed in 2013 in China. And before that, there's already an umbrella concept called nature-based solution, which is proposed in European countries. And like below his umbrella, there are some other similar concepts such as low impact development in America. water sensitive urban drainage in Australia, sustainable urban drainage system in the UK, and active, beautiful, and clean project in Singapore. So sponge city is a new concept. You can imagine the city like a sponge, so it can absorb the water when it's raining and store it, filter, and recycle and reuse it when we need that. So the sponge city using like green infrastructure such as rainwater gardens, wetland, green roofs, biospheres to deal with water issues like water pollution or urban flooding. So it can relieve the urban drainage system's pressure and slow the surface water flow. And it can also generate co-benefits like improve the biodiversity or air quality, and also create the aesthetic values and the social cultural benefit. And as you can see, before the sponge city was proposed, China focused more on the traditional engineering measures for the water management. But since 2013, the sponge city has set the short-term, medium-term, and long-term goals for the water management. So another background is about the public perception and public participation. So I categorize the different conceptualization of public perception levels in various disciplines, goals, and regions. So here I put two examples. The first one is earliest one in 1969 is Austin's leader of citizen participation. So she divided the participation level into 8 levels, from non-participation to the highest level of citizen power. And figure B shows another concept shape, which is the awning shape. So it maps the participation from the lower level, like the informing or inspiration, to the highest level, which is the inner shapes of the awning, is a co-production, collaboration, or co-design. And currently, we want to achieve the higher level of participation, like the partnership or citizen control. But unfortunately, we still, like most of the participation in China is still as a manipulation or consultation or tokenism. Okay. So my research, I propose 3 objectives. The first one, to identify the perception of spontaneity from government, media, and public perspectives, and then investigate the public participation status in terms of their approaches, their barriers, and their expectation to spontaneity, and finally to explore their interactions and the relationships among these 3 actors. So I use the policy analysis, media analysis, and interview analysis for my research topic. So currently in China, the expert cult is still the dominant phenomenon, like the top-down governance and the decision-making power is still controlled by the decision makers and experts rather than public, or like the bottom-up. So the public voice and the participation is underestimated currently. And the production of the scientific knowledge and the assessment of technocratic indicators still overweighting than public perception and behaviors. So that's why I want to do this research. I want to using the interdisciplinary knowledge and mix and match to investigate the issues of urban planning, the environmental management, especially on the sustainable water management, and also the media and communication issues covering the political science. So I mainly analyze some 3 actors, the government, media, and public. So by understanding their perceptions and the participation in Chinese context, we can give a wider environmental governance indicators and discuss whether the current situation is more democratic or is still like digital authoritarianism currently. So here is the first part of my research finding, the policy analysis. As we know, Smart City is a systematic and comprehensive project rather than just focus on water management. So Smart City concept has been mentioned more and more frequently in various relevant policy documents, such as the ecological civilization, like the national economic and the social development, or the air pollution prevention, river protection, urban and rural planning, or even the emergency system. And the Smart City spatial planning has been put into the central level. It has been incorporated into the master plan and the sectoral plan, such as the transportation plan, the green space plan, ecological protection plan, the water resources plan, and so on. And also supplemented by the regulatory detail plan, the constructive plan. And then I use Ningbo as a case. I mapped their stakeholders involved in Smart City case. And we found the construction and the housing committee is a leading office of Smart City construction. And they have a collaboration with the Financial Bureau and Water Resources Bureau and other local level district governments. And the figure B shows their labor division of Smart City construction in Ningbo from the earliest stage, like urban planning policy draft, to the construction level and the further maintenance level and the propaganda and public opinion reports. So you can see it covered lots of different institutions that need the collaboration of different stakeholders. So the second part is the media and the news analysis of Smart City. So in this part, I did online news analysis and social media analysis of Smart City. So I using the searching engine of Google News and also search on the major national newspaper website in China and outside of China, using the keyword like Smart City program, and so on. From and searching them from 2013 till the end of last year, and I called the online new data to the Unwaiver and did some semantic analysis and comparative analysis and content analysis. And you can see the there is an increased interest or coverage of Smart City news based on total news numbers of Smart City. And the trends in monthly coverage shows it consists with annual frequency of rainfall with a wet season. So from July and August, there are more news reporting about Smart City with raining seasons. And obviously, there are more Chinese news than non-Chinese news, and the sources are various. It depends on the media types and the hierarchy levels. And figure A and B shows the workload of codes. You can see the Chinese news and non-Chinese news. There are more strongly like positive words in Chinese news, such as completed, finished, innovation, effectively. And we also found the urban flood management is still the dominant function of Smart City, although they also mention other core benefits like the biodiversity, the air quality, and the social culture benefit. But however, the more climate like mentioned in the highlights in the non-Chinese news rather than in Chinese news. For example, in 2018, the Guardian report Turning City into Sponges, how Chinese Asian wisdom is taking on climate change. So Smart City in like foreigner news, they are more focused on the climate change. And the figure C shows the barrier to Smart City. And we find the two main barriers are social, political, and the financial factor rather than technical factors. So that's why I focus more on the social science part of the research. And the last section is the interview analysis. So I visited two parks in the Ningbo. One is the Xinsanjiang Park, another is the Eco Corridor Park. They are urban spawn parks with green infrastructure. So I visit park and observe their landscape design and identify their green infrastructure and map them into the landscape designing. So you can see how the different infrastructure combine together and play their role for water management. And then I interview some park users on the site. So figure A shows the samples of their demographic information, and the figure B showed a node tree of interviews from 3 sectors like public, media, and the government. So for each sector, I asked them 2 section question. Like first one is a perception to smart city, including their awareness, their understanding, and their knowledge to smart city, and the functions and benefits of smart city, and their perceived enablers and barriers of smart city implementation. And second section is perception to public participation, including their previous experience of participation, the forms, the procedures, and their barriers met, and also their expectations. And the barriers, including the individual barriers and structure barriers. And followed by the 2 sections, I evaluate their relationships with the media and the government. So the figure shows this triangular analytic framework between the media sector and public and government sector. As you can see, there are many different interactive forms like hotline, email, letter, media metrics like local apps, WeChat, Sina Weibo, or online news portals or BBS. And from the media to government, they also have the journalist internal reporting mechanism, so which is more efficient to report this urgent news. And the table shows PP forms, like including physical participation, civic participation, and online participation at the making phase and the keeping phase within the smart city topic. And I will give more detail in my conclusion. So for the conclusion, firstly, it's about public awareness, understanding, and their knowledge of smart city. So the government has informed the public about smart city, but their awareness and understanding still remain limited. And although the public appreciates the core benefits of urban smart parks, but they care more related to their personal interests like water logging sites, parking space, or local environment beauty and cleanliness or safety. And in my case study, the Ningbo people, they have higher flood risk due to the previous typhoon events. They also have higher awareness of the fire water management, we call 无水共治 in Zhejiang province. And secondly, is about the media reporting. And I found the smart city news topic are more focused on the urban resilience and urban regeneration. And its news numbers is consistent with the flood event and policy release. However, the local media like Ningbo case, the reporting smart city is more homogeneous and minimal compared to the national and the international media, which has more diverse topics and angles of the story. And the state-owned media in China, they still remain controlled the most central positions in the online news, and the social media within the case of smart city. And the public attention and the response rate is still quite low, and the discussion is quite limited. And also identify there are multiple roles of state-owned media, including the transmission of information and official government position to the public, and shaping their perceptions on issues, releasing the public emotions, building the contrast between the government and the public, and maintaining the stability and the harmony of the society. And interestingly, they mentioned some motivators of the media sector, like the facilitator, bridge, the loudspeaker, translator, or supervisor, mediator, or even the safety wallet and pressure cooker. Lastly, the public participation centers within smart city, I found it can be categorized according to physical and civic participation and the making and the keeping phase. And the public participation in China is still mainly conducted to improve the capacity of the state to exercise power in terms of agenda setting, policy making, project implementation, and government performance in a people-related and service-oriented state. And positively, the procedure norms of participation are becoming more standardized, and the communication approaches between the public and government are increasing with the help of media in the digital era. However, it seems most public, they still have a mental mode, like participation is only for those who are qualified or who are like professional. And they think it slows down the project implementation process. And so public participation is still at the early stage in China, and the tokenism forms dominant the process in most smart city contexts, and limited opportunities for deeper consultation or deliberative participation because of the barriers of the inherent governance structures and lack of interest and trust among these actors. So the question is, to what extent participation is instrumental as a political tool, or it intrinsically valued to empower the public and achieve the better environmental and the social outcomes? It's a question we need to think about in the future. And any further shortening of the distance between the government and public will depend on the complex interaction among the environmental, social, cultural, economic, and political factors. And there are associations between the physical environmental outcomes and decision processes are complex, shaped by the cultural and political norms and mediated by the powerful actors like the media I found in this research. Okay, that's all. Thank you. If you have any question, you can ask me now.
Okay, thank you very much for your wonderful speech. Now let's turn to questions and answers. You can hands up use on the bottom. Anyone have any questions? Okay, Yuan Ying.
Yeah. Hi, Lei. I've got a question for you, and I can see your research is more about human geography rather than physical geography. So that is a very brilliant method to link public engagement with our scientific perspectives. So my question is, what do you think the most difficult or the difficulties of sponge city to be widely applied in Chinese cities from the perspective of human or government perspective?
Okay, so that's a very good question. I found there are two main challenges for implementation smart city to a larger scale in China in the future. The first one is a financial issue, because previously it's funded by the government fundings or the municipal funding, but in the future there will be less money to investment to such public projects. So we need more innovative mechanisms like the PPP, private and public partnership, or some investment from the private the companies, or even the green bonds or loan to investigate the smart city. And the second one is because smart city cover different institutions like the housing and construction institution, the water conservancy or urban planning. So the communication between the different institutions is very important and complex, and who have the decision-making power and who can decide the planning or the implementation. We need to think about as a different city, different scale, and different regions is very different. So it's very local context, and we need to think specific case in specific context. Yeah, that's my answer.
Many thanks.
Okay, anyone have any questions? Yeah, I have a question about in your speech you remind 污水共治. Sorry, can you explain about 污水共治? What's meaning 污水共治 in Ningbo?
It's 污水共治 5, not 污水. So 5 water.
Sorry.
Don't worry. It's including the flooding management, the water pollution management, the water resources management, like water supply or water conservation. So it's like different perspective of the water management into one comprehensive single project.
Oh, okay. Misunderstanding. Yeah. Okay. Thank you very much for your wonderful speech. Okay, thank you very much.
Okay,
and now let's welcome our next speaker, Jiang Wei Zhang, who come from University of Leeds. Welcome.
Thank you. Can you hear me now?
Yeah.
Okay.
You can start.
Share my screen. Yeah.
You can share your screen now.
Yeah. Okay. Can you see my screen now?
Yes, I can.
Okay. Okay. Good morning and evening, everyone. My name is Zhang Jiangwei. I'm a PhD student.
Can you turn on the video, please?
Yeah. So good morning and evening, everyone. My name is Zhang Jiangwei. I'm a PhD student from University of Leeds. Today, I will share part of my work named Deep Recursive Neural Network for Water Prediction. And my presentation includes 4 parts. And the first part is introduction. As it mentioned in the UN report, global climate change has the drought all over the world and caused a lot of deaths. If we don't take any action on water resource management, a huge number of people will be at risk. And surface runoff is a major component of hydrological cycle. So surface runoff prediction plays a significant role in water resource planning and management. For example, the flood control, dam planning, and the reservoir operation. And the current surface runoff prediction method can be divided into process-driven method and data-driven method. A process-driven method are based on the partial differential equation and the linear equation, which describes the physics process. However, the surface runoff is affected by many uncertainty, non-stationary, and high non-linear factors. So it is very difficult to predict the surface runoff by a process-driven method accurately. And data-driven methods are also used for rain runoff prediction. Data-driven methods are a statistical method which just focused on the input and output relationships without considering the causality between factors in a specific system. And it attached many researchers' attention. Data-driven methods include the shallow learning method like SVM and the deep learning method like the deep neural network. Basically, deep learning method has a higher ability to present the complex function, and it outperforms the non-deep method. According to the input variables, the previous studies can be divided into 2 kinds. The first is to employ the rainfall data as input to predict the runoff, and the second is to use the multiple meteorologic data as input, enabling various factors related to runoff to be considered within the model. Although it is proved that multiple meteorology data has a better performance, limited research has been focused on the influence of different input variables on rainfall runoff prediction by using the deep RNN. It is even more significant under the current condition of the information explosion, as there are too much available data. So our aim is to identify the influence of different input variables on the rainfall runoff prediction and provide a framework to get a better input based on the multiple meteorological data. The next part is method and data. To achieve our aim, the Muskegon River and Pillow River in the United States was chosen as a study area as it's shown in the figure. And based on the USGS, NOAA, and other websites, we collected a lot of data, including 18 different kinds of meteorological data for Muskegon River and 50 different kinds of meteorological data for Pillow River, as is shown in the table. And for the learning method part, we choose to use the RNN framework as it has And before training the model, we normalize all data and do data collection based on the 6 theta rule and divide the data into training dataset and the testing dataset according to 90-20 rule. Specifically, the observed surface runoff is employed as the output, and the rainfall data, the meteorological data, and the meteorological data with PCA method are applied as 3 different kinds of input. And for the machine learning method part, we choose to use the RN framework as it has memory ability. This kind of networks can introduce the stat variables to store the past information and then determine the current output together with the current input. And in recent years, the hidden blocks in the RNNs is replaced by the LSTM's block and the GRU blocks to combat the exploding grant problem. And the next part is the result. The first one is the result of PCA. Time series data sets were normalized by their mean and variance, and the sparse 21 were used to identify the pre-simple component. We choose 5 components in each study area, and the cumulative variance contribution rates are boosted over 19%. The principal components matrix of time series dataset is shown as the table. And until now, we have 3 different kinds of input and 2 different kinds of blocks. Different hidden blocks and input were compared to evaluate their effect on model performance to identify the best hidden block and input combination. 6 different scenarios were proposed as in table to predict the runoff, and the regression method is also applied as the baseline model to provide the benchmarker. And then we try to train the model and test the model. Here are the results of 6 scenarios and the baseline model for Muskegon River. And here are results of 6 scenarios and the baseline model for Pillow River. And we use the NSE, RMSE, MAE, R-square to evaluate the performance of our model. Here are the model evaluation results. We can find that all deep learning models have better performance than the baseline model. Deep RNN models with multiple metrology data input has a better performance and rainfall data input only. With the same hidden block, the accuracy of deep RNN model with PCA input may outperform the model with normal multiple metrology data input. And the last part is conclusion. According to the result, we can make the conclusion that the selection of model input has a great influence on the model accuracy. Deep RNN models with multiple metrology data input achieves higher accuracy than rainfall data input for a surface runoff prediction. And the PCA method can be applied to improve the accuracy of deep RNN model effectively, as it can reflect the core information by classifying the original data information into several comprehensive variables. And the accuracy of deep LSTM's model and the deep GRU's model is much the same. Our work has been published on Journal of Hydrology on 2020, and until now it has been cited for several times. So that's all my presentation. Thank you for your attention.
Okay, thank you very much for your wonderful speech. And are you convenient to turn on the video, please? 能否打开摄像头？ We will take a screenshot.
Oh, sorry, I forget to turn on the video.
Okay. And now let's turn to questions and answers part. Anyone has any questions? You can hands up. Use the button. Anyone? Okay, welcome Xin Yao, Professor Yang.
Hello. Okay.
Yeah.
I'm not. I didn't fully understand your model. But I just have a question. When you are running the model, have you considered the contribution of groundwater to the surface runoff?
No. In our model, we just focused on the relationship between the climate data and the surface runoff data.
Okay, climate, that's rainfall. Okay, rainfall, evapotranspiration, right?
Yeah, including we consider the rainfall and the other climate data like the temperature and the pressure and the wind and other things to find a better input data to make a better prediction of surface runoff.
Okay, so you didn't consider the land type?
Yeah, we didn't consider that type.
Okay, it's a type of a statistical model.
Yeah. It's a data-driven model. So we use this kind of model in a specific system. I think the landscape didn't change. So in our black box, we didn't need to consider it.
Okay, thank you.
Thank you.
Okay, anyone else have any questions? You can hands up. Okay, thank you very much for your wonderful speech. Thank you very much. And now, let's warmly welcome our next speaker, Yuanyin Li, who comes from Durham University. Welcome.
Thank you. I will share my screen.
Okay.
Can you see it clear?
Yes.
Yeah. Right. Good morning, people in the UK, and good early evening, people in China. My name is Yuanyin, currently a final year PhD student of Durham University and the British Geological Survey, short for BGS. And I'm very glad to be the last presenter before we can take a break. So just bear with me for the next 15 minutes or so. Right. My presentation topic today is the potential impacts of future climate and land use changes on groundwater nitrates in England and Wales. And this is a brief outline of my presentation today. I'll first give a very brief introduction of the background, the aim of my study, and then basic workflow and modeling work I've used to complete my study, and to show you some major results on model outputs, and then a brief summary. Right. Nitrate water pollution, which is an international problem, not only deteriorates the natural environment, but threatens human health, thus causing social and economic problems. It has been identified as a major threat to the implementation of the government's 25-year environment plan in the UK. And groundwaters, as the vital part of England's drinking water resources, failed to achieve a good chemical status, primarily affected by its nitrate levels. And what's the major sources of nitrate in water? In DEFRA's most recent progress report, the main driver preventing water bodies achieving good status is the agricultural pollution, which accounts for 40% of the nitrate sources. And sewage and urban diffuse pollution are likely to be the main pollutants in urban areas. And in rural stretches of river, agricultural practice, like fertilizer applications, is likely to be the dominant form of pollution. And how those nitrates get into water bodies. This conceptual graph demonstrates nitrate processes in soil and water cycles. And the climate change will affect both the nitrate cycling and the hydrological flows. Coupled with the climatic drivers, changes in land use will affect the amount of nitrate applied and the soil conditions, further impacting the hydrological flows and nitrate cycling. So climate change and land use change play important roles in affecting the quantity, timing, and rate of nitrate-reaching waters. And besides, nitrate leached into the groundwater system travels slowly and could be trapped several decades before entering surface water, where base flow or springs. However, current environmental management approaches rarely consider this nitrate legacy, or it was considered but had to be applied to water land management practice. And there was lots of work to analyze water nitrates and existing climate and land use conditions, and nitrate modeling work provides an effective way in simulating nitrate processes in freshwater cycles and estimating or predicting nitrate concentrations in waters. For example, the figure in the left shows a map generated from the NIP-N model estimates soil nitrate leaching in England and Wales. Especially, nitrate time-bound model, short for NTB, simulates the nitrate legacy in the groundwater system and estimates the nitrate concentrations in a time series. Figure on the top right shows the conceptual model for NTB, and figure on the lower left shows the estimation of groundwater nitrate concentrations. However, it still has some gaps, like more detailed work is still required to investigate the impacts of vital drivers like climate change and land use change on nitrate processes in soil and waters. Therefore, it is timely and necessary to develop a comprehensive method for generating quantitative, temporal, and spatial predictions of the possible future groundwater nitrate concentrations. So the aim of this study is to answer the scientific question, what will the groundwater nitrate concentration trend will be like under the projected future land use and climate changes in the UK? And this is a simplified workflow of my research, which is a modeling-based research. The 4 yellow boxes indicate the 4 models developed, modified, or adapted to simulate the 4 major influencing factors or components of the nitrate cycle processes in soil and water systems. And for the land use change, a model called LUC-UK is a new model developed which can generate spatial temporal land use change maps for the UK based on the changing political, social, and economical factors and the 4 projected land use change scenarios. And for the climate change, the UK projections, short for UKCP, short for UK climate projections, specifically the 11 scenarios of future flow climate data applied by CH based on UKCP 09 was used in the initial estimation in the research. And a model short for SWAN-N, a soil water nutrient leaching model, nitrogen is adapted here for its outstanding strengths. For example, it is a distributed model, a process-based model, and it simulates nitrogen biogeochemical processes in the soils and water. And finally, the NTB model, as I mentioned earlier, nitrate time-bound, which has been mentioned earlier and considered the nitrate legacy in groundwater system, is applied in this research to simulate nitrate transport in groundwater system and finally estimate the trend in groundwater nitrate concentrations, which will provide useful support in making sound decisions to mitigate the nitrate water pollution in the UK. Right. So here come some key outcomes of those models. And firstly, is for the land use change model from the LUC UK, based on the storylines of IPCC special report on emission scenarios. 4 land use scenarios, A1, A2, and B1 and B2 were projected for the UK. And 7 different land use types, including cropland, grassland, forests, urban areas, were projected and quantitatively generated for the yearly spatial spatial temporal maps to the year 2080. And here is an example for cropland map in the year 2050. Compared with the baseline year 2000, both the density or percentage of the areas of agricultural land will decrease in 2050 for all the land use change scenarios, but with different spatial characteristics. However, all the maps in Figure 2 show the England has higher density of the agricultural land than Scotland and Wales. And the A1 and B1 has higher priorities in reducing agricultural lands in some areas, like the lice favored area, short for LFA, in most of the Wales. And the reduction will be equally distributed in Great Britain under scenarios A2 and B2. And we are discussing this with DEFRA as well for their preferred projections. And this slide shows some examples of the soil nitrogen leaching model SWAN outcomes for the catchment Eden and in the northwest of England. Figure on the left shows the comparison between modeled nitrate concentration with the observed river nitrates in river gauging station called Shipmount. And the figure on the right shows the monthly average nitrate leaching at the bottom of soil layer in Eden for 2006. And we can see an obvious changes in each month. Yeah, you can see the changes. And for the final estimation of the groundwater nitrates, here is an example for Chalk North Aquifer. This figure demonstrates yearly nitrate changes in the time series of this century and the projected 4 land use change scenarios. The gray area indicates the range of the nitrate changes under the 11 climate change scenarios. We can see for the Chalk North Aquifer, the groundwater nitrates are estimated to about the standard 37.5 milligram per liter required by the UK, and all the projected scenarios, which is worth to be considered when making land management decisions. It's all about this green dot line. And here I put the 4 graphs in one figure to show the comparison of the groundwater nitrates and each land use scenario. We can see a slightly difference between those trends in each scenario. And this is the final slide of my presentation. I will give a brief summary. The research links the rainfall, runoff, groundwater recharge and nitrate soil leaching model, land use change model, and nitrate time-bound model to estimate of the impacts of the major drivers on groundwater nitrate pollution. And the research provides a picture of possible groundwater nitrate concentration trends under the projected future UK's climate change and land use changes. And thus supporting policymakers to make sound decisions in water remediation and balancing the food production and environment protection. And the research method provides a feasible way to test if there is an updated or preferred land use or climate change scenarios to estimate groundwater nitrates. Right, so this is for the contact details. This is a link from my University Durham and including my emails here. So if there is any questions, that just feel free to ask. And thanks a lot for your attention. 你们可以用那个汉语提问。
Hello，
可以看到吗？
我有一个问题，你好，您能听到吗？
啊，可以听到，可以听到。
就是关于我看到您使用了四种不同的模型，是吧？
对，
就这张图。比较好奇的就是关于这个 leaching model 和 groundwater flow model 这2个之间是怎么考虑的？您是将这个 leaching 的 flux 作为 groundwater 的一个 boundary 条件呢，还是怎么样去关联这2个模型呢？
这是一个非常好的问题，就是我是先把这个土地利用和气候变化的这个相当于一个输入的值输入到了这个就是这个 nitrate 应该是翻译成中文硝酸盐磷溶的这个模型里面，然后硝酸盐磷溶的模型里面呢，它是一个基于这个模型经过一系列，哎，是不是我卡了？
能听到。
好的，可能是这个网不好。然后基于这个过程的模型呢，就是这个硝酸盐的零溶模型输出的结果作为一个就是输入到这个地下水的模型里，所以它应该是每一步的输入变成一个输出，然后再变成下一个模型的输入，它是一个整体的这样的一个comprehensive 的一个结合。
明白了。所以说就是这个 nature model 的这个输出作为 groundwater flow 的一个输入。
是的。
好的，谢谢。我还有一个小问题，就是在这个模拟中，有没有考虑这个 land use 的变化，还有这个 climate change 对于groundwater 对于 groundwater 的变化？比如说在 climate change 和 land use 的背景下，这个地下水的水位啊，然后还有它的补排关系，这些也有可能会发生一些变化。
其实是有的，因为这个它是一个整体的关于这个硝酸盐从土壤零溶到非饱和带到饱和带，也就是我们俗称的地下水，这个过程呢它是一体的。所以当我们在硝酸盐零溶的这个过程中考虑了 land use， 就是这个黄色的模块，还有 climate change 这个另一个黄色模块，其实它就是考虑了一个整体的这个土地利用和气候变化对整体系统的一个影响。那我们当然就是在不同的模型里面去考虑了这个模型，比如说这个土地利用模型，它是一个就是我开发了一个新的模型，它是基于很多种元素，比如说在这个结果展示里面，它就是我是从2000年以2000年为一个基点，去对未来的土地利用进行了一个预测，基于经济的因素、政策的因素、环境的因素，以及能考虑到的目前可以得到数据，或者是从这个文章里面得到的数据，去把它们做这样的一个整合而得到了一些参数，这样就能得到一个对未来的80年内我们可以对未来进行一个土地利用的预测。然后我们考虑了4种不同的场景，对未来进行了一个考量。第一种，这个我可能就是detailed一点，这个 A1 的模型，它就是把未来预测成一个偏向于 economically and globally oriented scenario， 就是它未来更基于经济的发展和全球化的发展的这样的一个模拟的这样的一个场景。然后这个 A2 呢，它就是把未来考虑成一个我们更加倾向于经济，但是我们更加区域化这样的一个导向的一个场景。然后B1 呢，就是我们未来更趋向于不是趋向于经济，我们未来更趋向于环境的导向和全球化发展的导向。然后这个 B2 就是未来是趋向于一个环境和一个区域性发展的角度。所以在每一个场景下，我们都将不同的因素，就是刚刚我提到的经济政策还有环境的因素有不同的参数值输入到这个模型里面，就会出现不同场景下未来的7种土地利用的模拟。像这个模型这个结果呢，它只是展示了这个 cropland， 就是这个作物的这个一种土地类型，它在2000年为一个基准，到2050年是一个什么样子。像这个表格里面就很清楚的表示出在不同的4种这个模拟环境下它的变化，就是基于2000年在2050年 A1 这个场景它变成了原来的0.69%，就是这个cropland， 然后 A2 呢就是这个变成了原来的61%，然后以此类推，大概是一个这样的这个解释，你还满意吗？
好的，谢谢你。
Okay. Anyone have any questions? You can use okay. Welcome, Professor Yang.
Hi, Yun. Let's talk. I have 2 questions. One is you have predict the future, the nitrate distribution. I wonder if you have validated your model with some historical data.
Yes, because we include 4 different parts of the whole comprehensive method. 4 different model we separately calibrate or validate. For example, for the soil nitrate leaching model and the groundwater nitrate model, it has been calibrated with the historical data. Here I can show you my results is an example of the nitrate soil nitrate leaching model. And here is the difference between the modeled data and the observed data. The red dot lines shows the model data, which is generated from my model, and the other is a black line shows from the historical and the real data. So that is the comparison. And the objective function, like the NSE value, is around like 0.7 or more. So that shows that this model is very convinced, I think.
Okay. My last question, have you considered the chemical reactions occurring in the soil and the groundwater? For example, some bacteria that they may cause nitrification or denitrification. Have your model considered the influence of such factors on the mass balance of the nitrate?
Yeah, and for the nitrate processes in soil and waters, we considered the processes because the SWAN model, as I just showed you, the result output from SWAN, it is a process-based model. That means it considers different interactions between nitrate and the environment, like the nitrate, water, and the air. Like here is the like a conceptual model. We consider about the nitrification, mineralization, etc. And if you want to know some details,
very good model.
Yeah.
Okay. Thank you to all the speakers for your wonderful speeches. And all of our presentation are finished. Next, let's warmly welcome Professor Yang, who is Director of the Laboratory of Regional Environment and Eco-Remediation of Shenyang University. Professor Yang to preside over the meeting. Thank you.
Hello, dear postgraduate students, dear committee members, and dear friends, and dear academic fellows. First, I would appreciate your contribution to this postgraduate forum. Without your hard work, we cannot achieve today's success. So thank you very much. Next, we are going to select the best oral presentations and the best posters with our UK partners. Also, we will select the best papers. You will get notified of the results. Thirdly, just want to let you know, our key lab is going to have a number of opening vacancies from assistant professor to associate and for professors. We are starting the recruitment the next year. So anyone have interest in joining us, please feel free to contact us. In the end, I would remind you, we are going to have another 4 well-prepared lectures oriented to our postgraduate students and instructing on how to writing scientific papers, etc. So I strongly recommend all our postgraduate students to wait till 7 o'clock Beijing time for the starting of that lecture series. Okay, now I will give my turn to Professor Yue Soyang. He's the director of our key laboratory.
Okay. Good evening, everyone from China, and good morning for those delegates from the UK. And I would say a few words before we move on to our next stage. So first, I really appreciate all your contribution. It's really, to my surprise, we have so many contributors from not only from China, Liaoning province, but also many from other provinces in China. And we have quite a few presenters from the UK. For example, earlier session, we have very interesting, the very comprehensive study. Of course, most of your presenter working in the UK originate from China. That's good news anyway. So thank you very much indeed. We had about 3 sessions yesterday, 20 talks, and 10 talks today, various from different fields of our environmental science and engineering field. So this is very interesting. I really appreciate all your talk and some conversation, some discussion after talk has to be very interesting and very active. That you very good. So following a conclusion of our seminar, we are going to, as Xinyo mentioned earlier, we're going to select 6 top oral presentation and 6 posters. So this will be maybe good motivation for all of you to carry on and try to join more, academic exchange, something like this. Okay, something maybe I can suggest for our domestic contributor. It might be worthwhile to encourage yourself to present and to involve more discussion using English. Anyway, this is a tool as language, so nothing more, nothing less. Okay, finally, may I remind you that there will be 4 more talks starting 7 o'clock, so half an hour time. They're going to show you how to write scientific paper, how to propose scientific research, whatever. I assume that would be very useful for all of us. So thank you very much, and hope you can communicate from here in the future for more academic exchange. Specifically, if you have any problem or any query regarding your research leading to your PhD or MSc research, I think it's a good chance you can set up network, for people involved in the conference seminar. Okay, thank you very much. That's all. Xinyo, would you say anything else?
Okay, thank you, Professor Yasuya. Thank you for all the participants, and let's wait till 7 o'clock. Let's join the next 4 lectures together, and also all the best wishes to our postgraduate students. Wish you successful in your pursuit in academic success and in your future career. Also, we look forward to your joining us in the coming year. Bye for now.
Okay, bye-bye.
Thanks.
Bye-bye.
Thanks for professors, and maybe we can take photo together for speakers, posters, professors, and also our audience. Maybe we can turn on the camera, and I will click the screen and get a photo. Yeah.
Yeah, that's fine.
Okay, speakers and posters, please turn on the camera, and we will take photo together, and then we will wait for another meeting at 7 o'clock.
请同学们打开摄像头，我们拍张合影啊。
好的，还有几位同学没有开摄像头，我们打开，然后一起合一个影。
It's a little bit sad that we're not able to see all missing face. Hopefully next year it should be much better.
Yeah.
The policy is changing. However, coming to the force, coming to reality, still need some time.
明年应该就好了，明年这个疫情应
Wow.
该会没有。
Okay, we have finished the photo saved, and thank you for all of you. Thank you.
Thank you.
好 ，Thank you.
Thank you very much. Thank you. Bye bye.
拜拜。
Bye.
Bye.